All right, so we have a two-part video. We're going to be doing MicroPython for the first time. We're going to be doing two drivers from scratch just to demo how it's done using a different language. Obviously, there are more complete drivers online that you can download, but this should show you how to write something from the beginning. So we're going to be writing a driver for the NRF. You see, yeah, this little tiny thing, the NRF24. And then we're going to send data to this other one that is going to receive the data. This one already has code in C++ from previous videos. And we'll see the data come in through the Bluetooth on my phone. After that video, we'll do another one to utilize the ADS1115. It's an ADC driver. We'll configure it with a pico so we can get input from these two joysticks, send it over via the NRF to this unit, and then see it on the phone. So let's get started. Switch my view. So we're going to be using this as a reference. This is my previous NRF24 driver in C++. And obviously, we're just going to dive into writing code. And this one, this is the connection pinout that I have for my NRF24. So let's start by importing utime, and then from machine we'll import SPI. We'll do the same for pen. Begin the class. We'll do the class on the same file. Once we have it working, we'll move it into its own file so it can be used as a library. So NRF. And then we'll do the constructor. This one takes a port, default 1, because we are connected to SPI port number 1. And then MISO will be 12, and then 11, 10, and then CSN 9 and 8. So 12, MOSI 11, and SCK 10, CSN 9, and CE equals 8. Okay, so that's the the declaration of the constructor. For this one, we'll define CSN to be CSN as an output. CE will be as well an output. And we can define our SPI. This one takes a port, takes speed. Let's see. SPI. So it takes all of these parameters, and we're only going to define these three parameters plus the baud rate or the speed and the port. The port should be somewhere here. SPI somewhere in here. It's not giving me the port, but I know it takes a port, so it takes speed. So this will be a 1 megahertz, 1, 2, 3, and then we'll do the MISO, MOSI, SCK, and that will be our declaration or instantiation of the SPI. We'll need a couple of helper functions. Oh, it's hot here. So CSN high, and this will be CSN CSN low, send low, and we'll copy this. Do the same for CE. Okay, now that we have those two, we can use them. Tell CSN high. Now, a lot of what I'm going to be typing is from memory from previous videos that I did for C++, for ARM and the Pico. So if you need a reference, you can always get it from here. This is where I'm getting all my values. So CE will be low, and I'll explain why in a minute. And then we'll sleep for 11 milliseconds. So that should get our class initiated. Now we can, let's see if we can read the configuration, the address 0. So it should give us 00. Disconnect my unit. Reconnect it, make sure everything's clear. So we should get 0001 for configuration 0. That's the default value. So this is the reset values. So let's read a register, and these ones are incorrect. They require self. And we need a register, also data, actually size. So first thing, we need to mask the register. So this will be, the masking is little commands. So for reading a register, this is the mask we're going to use. And it will be plus the register. Okay. So that is the mask. And actually, we don't need this one. We should be able to do it with just that. And what this is all the A's have to be ones. So 1, 2, 3, 4, 5. That's our register. And then we'll set the CSN to low. That initiates the communication to the NRF. SPI, we're going to write a byte array of whatever we have on a register. And then we can go and read the register. We can put it in a separate variable. Let's call it results or result. SPI read, and we read whatever size we want for this data. And we're going to default this to 1, so we don't have to type it all the time unless we need more than 1. Now we can stop communication. So CSN high and return result. So we should be able to test this now. If it's correct, we should be able to read the configuration and possibly see what else we can do. So we'll read the config, and we'll read something that has more data, 80, this right here. We should get all of this data. So let's get NRF, a copy of NRF. And I'm not providing any variables because I have all my defaults, and my defaults match my connection. I will do a loop, and we'll just put it in A. And we'll say NRF read register. That is the register 0, actually just 0. And then we'll print. Well, let's do this. Let's just print it in binary. So that should give us the data. Okay. And we'll print it also regular. So we'll just print A. So we'll do 2 prints, and we'll sleep for 1 second. So every 1 second, we'll get the values. Let me stop this. Let me run it. And this window always pops up somewhere else. I have to use the keyboard for shortcuts to make it attached to the mouse. We'll name it main.py. That will be the main executable. We'll run it. We have the first error. It's a syntax error on line number 3. So let's see what line number 3 is. So it's a typo. Put it again. We have another syntax error on line 34. So let's go to line 34. Right here, it requires an equal sign. And now we have real errors here. So NRF object has not been attributing CSN high. So there's a mistake there. Right, so that one doesn't exist. It's an H. And there it is. So now we're reading register 0, which means it's this one here. And we should get bit number 0 is a 0, 0, 0, and then a 1. So 3 zeros and a 1. That's what we have. Let's go and read A0. So we should get all of those EX, EX, whatever that is. I mean E7s. So let's read 0x0a, and it's going to be 5 bytes. Let's see what we get. So we have the E7, E7, and then the binary representation of each byte. So we're good to go. Now what we can read, we should be able to write. So let's write a register. And for this one, we'll require a register and the data we're going to write. Same as before, we need the command. We require this command here. Not command, but the mask. And the command as well is 001. So we'll do register and that one, and then that one, and the register. So the first one, this one here, this is going to flag it. So it's going to be 0, 1, 2, 3, 4, 5. And then on this one, we just need all zeros, 1, 2, 3, 4, 5. So we want this byte to be sent as 1 at all times, and the last two as 0. And then to the left or to the right is our data. Okay, so we can say self CSN low and self SPI write, and we're going to write a byte array, and we're going to use the register, and now self SPI write byte array data, and last is self CSN high, and that's it. Now when we send data here, we're either going to be sending a value or a string, so we have to compensate for that. So let's redefine data, and we'll say data is going to be equals data if the type of data is equals to integer type. Else, we'll just say data. Right? So if it's an integer type, then it will be this type, and if it's not, then it will be this type. And that should allow us to send either or. So let's test it. Let's see if it works. Let's change the E7 to some other data. So NRF, right, register, and we'll write the S0AX, and we'll put G user. Write it. Let's see, we're gonna get errors, of course. Line 38. What is the issue here? Let's see. Invalid syntax. So data equals data. Data equals data if type data. Oh, needs one more equal sign. Run it. NRF object has no attributes. CSN low, so that's a typo. Oops. Okay, there's another one. CSN low. Oh, CSN high or CSN low. There we go. So there we go. Now we can see that we are getting G user, and it has the binary representation of G user. So now to test, we also want to test on the configuration to see what we have, right? So we should be able to change that configuration and write something else to it. right register 0, and we'll put a 3 in it and see if it writes it. So you can see it did write it, and we're reading it. So this is changing the data type depending on what's coming across, right? So you don't always have it as some type of uh, array. Okay. So now that we have that, now we can configure, and we can go to commands to see what register map to see what we're going to configure. Okay. So let's do the configuration. So we'll just call it config. This one will take a channel name, and probably the packet size. That's it. So first thing we're going to do is we'll bring this down and put it here. Okay. Now we can SPI, right? Actually self, right? Register. Now we can set the configuration, and the configuration is going to be according to the flow. 11 milliseconds after power up, then we can set this bit power up to 1 and wait 1.5 milliseconds. So we'll go to the register map, and this is the bit we're going to set, bit number 1. And then we're going to keep this one as 1 as well. Where are we? So it's going to be 1, 2, 3, 4, 1, 2, 3, 4. And we said we're going to do number 1 and this one as well. So this is the config. That's all we're doing. Next one, it's a delay, sleep microseconds. And I don't remember, I think it was 1.5 microseconds. Yeah. So, I mean, milliseconds. So it would be 1500 microseconds. Okay, so next, we're gonna leave this enable just so we can capture more data, more reliable. So we're gonna enable acknowledge by not changing it. By default, it's set to once. And obviously, if you wanna make sure that it is set, we can always just say self right register, and it will be number 1, B, 1, 2, 3, 1, 2, 1, 2, 3, 4. Is it 4? 4. And then the last two, which are the only two we need, pipe 0 and pipe 1. Okay, so the next one will be the channel number 5 right here. Right, this right here. So actually, let's maximize the number of retries to 15. This one here. So it's number 4. So self right register. It says 4. Yeah. 1, 2, 3, 4. 1, 2, 3, 4. There you go. So this will be the max retry, and then self right register. The next one is number 5 channel, and that one we're passing it along. Okay, next one, let's put a space, right register, and this one is the one we were playing with, which is A0 for the name, and it will be whatever channel name we decided to give it. And we're going to do the same for 11. And last will be right register, actually not 11, 10. And this one is this one here, how many bytes we're going to be sending. That will be the packet size. So it will most likely be 32, and in fact, we're gonna set it to default to 32, and we're gonna have the channel name default to uh, gyro C, because that's what my receiving unit is looking for, and default channel 16. Okay, so that should take care of this configuration. So now to see if it works, we are going to just say NRF config, and we should see a difference in this. Instead of being 1, 1, it should be 0, 1, 0, 1. Okay, so let's see. And we have issues, obviously. Config. And channel name is misspelled. Okay, so now you can see that is 1010 or 0101, reading it backwards from the bottom up. All right, next function. So now that we can configure it and we can read and write, we should be able to set the mode to either text or RX. And we'll start with text. So let's go back to my reference to this one to see what we need to do. So we have to read the register or the configuration, set bit number 1 to 0, write it back, CSN low. So set CE low and then wait 130 microseconds. So let me put this right here so I can see it. And so let's read the config, and it will be self read register configuration is 0, the first bit or the first byte, and then it'll be reg. We need to set it to 0, and then we write it. Right, so write register, and the register is 0, and it'll be the reg or register. Then CE low and U time sleep microseconds 130. Okay, so that should do it. The next one is going to be mode RX. This is for receiving data. What do we want? Some mosquito here. Where is it? All right. We want to read the register again. Read register. It's still coming. Oh, it's hot in here. All right. We read the register and then we set it to 1. In reality, we could just say 1, right? The same thing, but just to keep consistent. There. Self, right, register, 0, register, and then CE high and U time speed microseconds 130. Okay, we're set. So now that we can change the mode, we can test it. So right here, we'll change the NRF mode to RX, and we should see the first bit change to 1. Typos all the time. CE high isn't defined. So there's CE high. Oh, forgot the self. All right, so you can see the first bit is 1. So if right after that I change it to mode TX, it should have a 0 again. Whoa. I did the same here. Yes, I did. Self. Okay, so there's a 0, and if I comment this one out, it should be a 1. All right, so we can change the mode back and forth. Next should be able to send a message. So let's just send a message, and this will take self. What else do we need? We need the message. So this is going to be the data. To send the data, I believe we need a command, and the command would be this one to transmit payload. So we need this guy right here. And we are going to mask it as well. Not with the register. Sorry, this is not. I'm getting confused here. It's just the command. So to write this command, we simply say, actually, before we write the command, let's also, when we want to send a message, let's just flush tx just for good measure. So if the previous message is still waiting, no, it doesn't really matter because we're about to send a new one, and we're just gonna plot the other unit with messages anyway. So let's do self CSN low and self SPI right. Byte array the command for text. Okay, and then missing one. There we go. Self CSN high, and right after that we can say self CSN low, and now we can send our SPI right, the register. Actually, we don't need that. We need to send. Yes, we do. We need to send the command, so it will be byte array register. What else we need to do? We need to load the data. So now we need to send the data. Now the data needs to be, because we said it was going to be 32 bytes. Obviously it would be ideal to keep that this reference somewhere else, but we're not going to do this in this driver. We're just going to assume that every message is going to be 32 bytes. So the message going out needs to be padded with zeros for 32 bytes before we can send it. So one way of doing that, we'll just say local data, and this will be byte array, and obviously we can send everything, including this, in one long message, but we'll do it too. So byte array, and this will be my data. So now that I have this, I can actually let's set the size as well, so we'll have access to it, and size will be defaulted to 32 bytes. So now I can say local data extend, and it will be a byte array of size minus the length of local data. All right, so that should give us a 32 byte array we can send. Self SPI write, and we'll send the byte array local data. Okay, and then we can say self CSN high, and according to the flow, let's see. If you want to send data, you need to pulse CE for 10 microseconds, right? So we're already in text, so now we just need to pulse it, and we'll say self CE high. I don't know if I need to take this into account, those 130 microseconds, but we'll just add 200 for good measure. Actually, not there. it'll be under U times the microseconds 200. Okay, and then we set it to load. Okay, so once we have that, we need one more thing. We need to clear bit number 5. Just in case this is set, we need to clear it in order to continue sending data. So bit number 5 needs to be cleared. So when we do that, well, we read self read register, and it's number 7, the first byte, and then we'll say reg equals bit number 5 is what we said, right? Is it 5? 1, 2, 3, 4, 5. Yes, 5. Okay, and then we write it back. So self write register, and it's 7 register, and I believe that's it. What is the next thing we need to do here? Well, we can send data now. So let me compile it first. Okay. And let me show the phone. Let me open what I have. Let's bring our console over so we can see what we have as we start printing. Let's make this bigger. Make it 20 lines. 400 by 550. And right there. Yeah. Okay. Let's see. All right. So let's see if we can send data and receive it on my phone, and then we'll do more detail. So we need to change this to TX. We don't need this anymore. We don't need that either. We have the config. We don't need any of this. And then we'll say NRF send message MicroPython sucks. Okay. And every 1 second we'll send it. It's likely that we're gonna miss some packets, but most of them should get to the phone. So let's run it and see where we made mistakes. And there's the first error. Right register needs to be uppercase with the R. What would that be? Oh, it's on line 99. It's telling me right there. 99, right here. Okay, running again. Okay, it's running, but we're not getting any data. So let's see why not. So let's do a few things. So here, under data before we print it, let's print local data. See what we have. All right, so it's 32 bytes. It is sending data. Let's see. 1, 2, 3, 4. 1, 2, 3, 4. That's fine. Configuration is fine. Register number 1, 1, 2, 3, 4, 1, 2, 3, 4. It's fine as well. Let's look at the mode, see what we have. So let's hey, NRF register 0, 0, and then we'll print A. See what we have as far as the config. So it is 0 is for text mode, and we are setting channel 16 name gyro C, packet size 32. So that's the channel. What am I missing here? So this is correct. This is correct. Let's look at other registers to see what we have. So we'll get NRF read register, we'll read register number 7, and we'll print bin. Actually, let's just, whatever we get, we'll print it. So it will be bin I for I in, what was it, 8? Okay. And actually, let's do one more thing here. So we'll do, what is this, status. We have an invalid syntax. All right, this is, yeah, this is incorrect. Actually, this whole thing is incorrect. It should be like this. And we have one too many. No, still not. Still no bueno. Doesn't matter. All right, so let's do a 0, and then we'll do that. All right, so the status is flipping back and forth. So bin number 5, that should not be an issue though. Oh, I'm sorry. We're likely getting data. It's just that I haven't configured my phone to receive data. There's no connection, right? Waiting for data. So I need to connect to the unit, and we should be, there's the data, right? MicroPython sucks. So you can see the data coming across. I guess if I make it a little bit faster, 1/10 of a second, then you can see the data start scrolling over rather quickly. So obviously at this point you could get data. You could start writing. You can actually start also receiving data, since you can change the mode. So for receiving data, it would be, I guess, read message, and size, maybe, I guess. And we'll default it to 32. And for this one, rigging a payload would be this right here. So it will be similar to the one up here, where you just specify the register. Let me stop this because it's sending too much data and it's slow. It's very slow. So register, and it will be that. So that's the first command we need to send. And in theory, we should be able to simply say return self read register and the size. That should be enough to receive data, I believe. I'm not sure, but it will do a write to that register, and then it will get that number of bytes back. So we go and examine the read register, this one. So when we bring it over, actually it will not do that because of this masking. So we'll have to do it individually. So what we need to do now is say self CSN low, and after this is self SPI, right? And we write a byte array register, then self SPI read, and we can put the result here. That would be the message, and we'll read the size, whatever number of bytes we're going to get. Self C, so typo here, CSN high return result. I believe that should do it. Let me go look at my reference to see if that's all we need. So for receiving a message is sending the command CSN low. Yep, that's all we need. Obviously, we're not going to test it because we're not sending data over, but that is the driver. Right? It's minimum driver. You can't really set all the parameters that you can set, but enough to get you going. You have a channel machine name or channel name, and then the packet size. And obviously, you can configure switch modes back and forth. It has a lot of defaults, obviously. You know, it has a maximum retry of 15, enabling the 2 channels to acknowledge. And the initial configuration is just power up. We're setting channel name, packet size, switching from mode to mode, and sending messages, right? Pretty sure we can get away with this with a little less than that. Let's see. Yeah, still works. Okay, so let me switch my view. So now we have, where's my phone? Enable it as well. So you're seeing the same thing, right? If I move it, you'll see it's the same one. There's this little delay, but that's the same one. So this unit here is sending data via NRF to this one, and then the pico is getting that data, sending it through this Bluetooth via serial communication back to the phone. So that's it for this video. I'm just gonna on the next video, I'm gonna switch it over to a separate file so it becomes a libraries. But on the next video, we'll do a driver for this one to get input from these 2 joysticks. And now that we can communicate, we'll send it via the NRF. All right, and I will upload the video. I will upload the code for you guys to download, but it would be good if you practice writing it yourself so you understand exactly what is going on, as opposed to just copying and pasting. That doesn't teach you anything because when it breaks, you have no way of fixing it. All right, enjoy.